Welcome to one more video on the topic of self-inductance. Now, what I will do is I will talk about the mathematical modeling and how do you represent self-inductance, which is the concept we studied in our previous videos. So this is your self-inductance, and what we're studying is the mathematical modeling, okay? When we do mathematical modeling, if you see all the books, what you see is that if you have a circuit, you have a circuit. Now, when I say circuit, I mean, it could be a solenoid, okay? So this is your solenoid, okay? A solenoid is a circuit. When I study the chapter of electromagnetic induction, generally the kind of circuits I study, one of the most famous one is, this loopy thing called as solenoid, okay? This is just an example. Now, the concept being studied is essentially mathematical in nature. So you might have seen, this expression, which is the total flux which is associated with the circuit when the current I flows through it is given by L into I, okay? This expression, gives you, this is N is the number of turns, N is the number of turns, okay, in the circuit. The flux phi is generated by this current I, and L is a constant of proportionality, and now it's basically a geometrical concept. This is the inductance, and this is purely it's expressed in henries. So this is one mathematical model which you should understand, which is this. Right? When you're solving the numericals, you must understand that number of turns multiplied with the flux associated with the circuit is equal to L into I. And I wrote L because I'm studying self-inductance. The second formula or mathematical expression of the Lenz's law or Faraday's law is the fact that the EMF, which gets produced in a circuit is nothing but L di by dt, right? So there are certain numericals in which you have to use n phi is equal to Li, and there are certain numericals in which you have to use these. So you could get a numerical in which you have to use 1 and 2 both. So these are two, very important, laws, mathematical representation of the laws or concepts of inductance that you must understand when you're trying to solve the numericals associated with self-inductance. So just go through them, try to understand. This is in volts, obviously. This is in Henry. Change of current, which is, maybe I2 minus I1 is in amperes, and dt, is in seconds. Okay, so this is one expression. This is number of turns, it is dimensionless. Flux is in Webers, and L is in Henry, and I is again in current. So you need to understand the concept number one and the second important mathematical representation, which is EMF is equal to L di by dt. Both are very, very important for your entrance exam and school exam. So I hope this helps you. Thank you very much.